If humanity wants to explore the universe, we'll have to learn how to colonize and terraform other worlds. But what exactly would it take to terraform a planet? And do we have the technology to make a planet like Mars comfortable for us? Discover what stands in our way of terraforming, which places in our solar system are the best for human colonies to be built, and find out how we just created oxygen for the first time on another planet. Planet Earth is the only place where humans can exist, for now. It's a scary thought that if our planet suddenly started to become uninhabitable, we'd have no place to go. Mars is one planet in our solar system that could be colonized. NASA wants to put humans there sometime in the 2030s. But when we send humans to Mars, they'll need a way to return to Earth safely, and those astronauts will also need oxygen to breathe. Mars is a cold and desolate world with a thin atmosphere that's made up of 96% carbon dioxide. NASA already has several rovers running around on the Martian surface checking it out, looking for signs of ancient life and seeing how habitable the planet might be. The Perseverance rover recently landed there, and it brought with it a very important experiment called MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment. It's a small toaster-sized box that has three main components. On April 20th, 2021, MOXIE became the first instrument to create oxygen on another planet by separating oxygen atoms from carbon dioxide molecules while using high levels of heat for the conversion. During the first run of MOXIE, it produced about 5 grams of oxygen. That's about 10 minutes worth of breathable oxygen for an astronaut. But this small car battery-sized unit can only generate 10 grams an hour. But now that MOXIE has proven it can produce oxygen, NASA plans to build a much larger unit, about 100 times larger. Another big achievement of MOXIE is that it's the first kind of technology that just used elements of another world's environment and turned it into a usable resource. NASA calls it in situ resource utilization. Oxygen is also needed for rockets, and to get off Mars, a ship or rocket would need about 33 to 55 tons of fuel. That's where liquid oxygen comes in. Mars-made liquid oxygen could supply more than 3/4 of the fuel needed to explore the red planet, and could also fuel other missions to nearby planets and moons. And if you mix hydrogen and oxygen together, you either produce water or hydrogen peroxide. And water is another important resource that we're going to need. 3 billion years ago, an ocean covered 1/3 of the Martian surface, but now 99% of Mars water is ice. It should be possible to melt this ice and filter it so that it can be used. When it comes to colonizing the planet Mars, we could build big domes and pressurize those with a breathable atmosphere using a MOXIE system. But building domes and living inside them is no easy task, and we need to be sure we're up for that challenge. Take, for instance, the Biosphere Project, which was a compound built in Arizona to see if we humans are able to build and live in self-sustaining colonies in outer space. We have a more in-depth video on the Biosphere Project you can check out. Thanks to this project, we now probably understand exactly what we need to build these domes out of, and how we might be able to survive inside of them. Technology has come a long way since then, and Elon Musk says that we would live in big domes made of glass at first, and then we'd eventually terraform the planet over time. Colonizing Mars definitely seems possible, but is it really possible to terraform the planet? For those who don't know, terraforming is the process of taking a barren or desolate planet like Mars and turning it into an Earth-like or somewhat habitable environment. It sounds good in science fiction stories, but Mars has big problems that our current technology cannot overcome, not as of yet. Mars has a very low atmospheric pressure, currently less than 1% of the Earth. That pressure would have to be increased a lot to sustain an atmosphere. Elon Musk joked about an idea to nuke the polar ice caps on Mars, and minerals and soil could also provide a source of CO2. But Even if we used nuclear weapons and processed all those sources, we would only increase atmospheric pressure to about 7% of the Earth, which is 1,013.25 millibars, or about 14.7 pounds per square inch. That means that any liquid water on the surface of Mars would freeze or evaporate quickly. And using nuclear weapons might only put the planet into a nuclear winter. It's still possible that there is enough carbon-bearing materials buried deep in the Martian crust that might hold enough CO2 to reach the pressure needed, but no one knows this for certain yet. But it's not the only problem. Mars is missing a magnetosphere, which means it will be difficult to maintain an atmosphere and ozone layer protecting the planet from solar radiation. And because the planet lacks any plate tectonics, it makes it incredibly difficult to introduce and isolate the proper amount of greenhouse gases life needs to survive. Mars also has lower gravity. Now, you might think it wouldn't be a problem, but lower gravity poses high health risks like bone demineralization, muscle atrophy, and weaker immune systems, as seen in some of our astronauts at the International Space Station. Mars is a cold and desolate place. But why fly to another planet if we want to try terraforming a cold and frozen wasteland? It seems the USSR wanted to do something similar, where palm trees could grow in Siberia, and the cold sea shores would turn into sunny, sandy beaches full of tourists. In the 1960s, there was a proposed plan by a Russian engineer named Petr Borisov, who wanted to build a dam across the Bering Strait. The reason is that 80 million years ago, at the boundary between the Mesozoic and Cenozoic, the Earth was in one of its most favorable states. The latitudes of Siberia and Alaska were in the subtropical zone, and the Arctic islands and Antarctica were covered with forest. All that's needed to return the area to this state is to restore the Cenozoic water exchange between the polar basin and the equatorial seas. But building a dam like this would take an incredible amount of resources. The width of the strait in the narrowest part is 45 miles, and the maximum depth is 193 feet. It was proposed to build the dam from large reinforced concrete blocks delivered by the sea. The width of the pontoon blocks would have to be 131 feet by 820 feet long, with a height of 65 to 196 feet. The dam itself would have been 55 miles long. The result would have been an increased flow of heat to the Arctic, and gradually the Arctic Ocean would lose all its ice, and temperatures in the northern part of Eurasia will increase. Of course, this project never took place, and we can already see the warming of Siberia now. But what about something not on Earth, but right next door? It turns out that the Moon has long been considered a potential site for terraforming. One of the reasons it would be easier is because it's a lot closer to us than Mars, and transporting people and equipment would take a lot less time. Because it's close, any resources or products made on the Moon could be shuttled to Earth in much less time. And a tourist industry would definitely pop up with people wanting to go to the Moon for their vacation. But the Moon has a really thin atmosphere, if any at all. And the volatile elements needed for life don't exist there or are in short supply. In an impossible task of creating an atmosphere, you'd need to bombard the surface of the Moon with comets that contain water ice that would release gases and water vapor. The presence of water ice in the lunar soil and large patches around the southern polar region could be used to create surface water once a greenhouse effect was triggered. Getting the Moon to start to rotate again by crashing asteroids into it, since it's tidally locked to Earth, would also have to be achieved. All this sounds really impossible. But there's another idea to terraform a place on the Moon called Shackleton Crater, where scientists have already found evidence of water ice. By using solar mirrors and building a dome over the 13-mile-long and 2.6-mile-deep crater, a microclimate could be created where plants could be grown and a breathable atmosphere created. Once again, we lack the technology to pull any of this off, but it still might be possible to see some type of subsurface installation built on the Moon for future human explorers. Another surprising place that we might be able to terraform one day is Venus. Venus is considered Earth's twin because they're almost the same size in mass and are rocky terrestrial planets. Venus also orbits the Sun in the habitable zone, and it's close, making it easier to transport explorers and supplies. The gravity of Venus is about 90% of what we experience here on Earth. Venus doesn't have a problem with a thin atmosphere. In fact, it's the opposite. and is 90 times thicker than the Earth's. The surface of the planet is also hot enough to melt lead, and the air is a toxic combination of carbon dioxide and sulfuric acid. It definitely doesn't sound like a place you want to visit anytime soon. But despite this being a hellish world, scientists think it's a better candidate for terraforming than Mars. Reducing the heat in the atmosphere would be the first thing on the list, but this would require a huge amount of energy and resources. Using advanced materials which likely don't exist yet, a huge orbital shade large enough to cool the atmosphere enough could be built. However, we're talking about a structure that would need to be 4 times as big as Venus itself, and it would have to be assembled in space, which would require a massive fleet of robot assemblers. Increasing the speed of Venus's rotation would also have to be done, and this would require a huge amount of energy, such as directing several asteroids into the planet using large fleets of spaceships equipped with advanced drive systems. But thousands of impactors would be needed. But there is even another world out there that scientists say could be terraformed. The Saturn moon Titan is appealing as a place to terraform because of its vast reservoir of resources. Its hydrocarbon reserves, such as petroleum, are several hundred times greater than all known reserves on Earth. It's covered in a wide variety of organic compounds, mostly methane and ammonia, and it has a lot of water. Its atmosphere is primarily nitrogen, resembling that of early Earth. Together, all this stuff has the main ingredients for a perfect place to terraform, when we have the technology. To change the atmosphere, one idea is to position huge mirrors in orbit to direct sunlight onto the moon's icy surface, which is ice and contains many greenhouse gases. This could warm the place up considerably and at the same time release water vapor, which would in turn oxygenate the atmosphere. Titan also orbits most of the time with Saturn's magnetosphere, which would protect it from the solar wind. Despite all the major technological challenges we face, most of humanity believes that we need to find a second home in our solar system. The big question is, which one should it be, and when will it happen? Let us know what you think, and make sure to stay tuned here for more amazing videos of our planet and the universe we live in. Thanks for watching.